All right, so on page 1 of this file, there were several things that we went over in class. You might want to just read and review all of this stuff on page 1 before you get back into things with this first video. So this is for example 2, and we want to figure out the null and alternative hypotheses in part A. And again, make sure that you've read what the example is about. If you haven't, then you should pause the video and just read the scenario for the example. Now, in order to figure out the null and alternative hypotheses, we really need to know what kind of variable we're working with. So even though it wasn't asked for, it's a good idea to figure out what are the observational units. In this case, it would be the students that were sampled and surveyed. And the variable, what was recorded on each student, is whether or not that student lives in the dorm. And then that is a categorical and, in fact, binary variable. They either live in the dorm or they don't. All right, so knowing that our variable is categorical, then we're going to use pi for our parameter. So that means our hypotheses are going to be about this parameter pi. Now the thing is, I'm actually going to write this out at the beginning of part A. Usually we've been saying that pi is a long-run proportion of success. And now we're going to expand that a little bit. In this particular case, we have to think about not a long run, but a population. And so in this case, pi is the proportion of all students at Sasha's school that live in the dorms. So we're going to have to change gears now. Sometimes when we have to describe the parameter of interest and the symbol is pi, we'll start with the proportion of all and whatever our observational units are, rather than starting with the long run proportion that. So this is something that we have to now start to get used to. All right, so our null hypothesis, this is also a little bit different than what we're used to, because we wouldn't really suggest that students live in the dorms by chance. So we're used to thinking of the null hypothesis as the by chance explanation. Now we're going to expand on that and add to it. So in fact, since pi is the proportion of all students that live on campus, and Sasha is trying to figure out whether her friend, who's told her that 60% of students live in the dorms, she's trying to figure out whether her friend is correct. What we're going to do is start by assuming that her friend is in fact correct. So we're not assuming that things are due to random chance. We're assuming that the claim made by Sasha's friend is the truth. So we're going to assume in the null hypothesis that in fact 60% of all students on campus live in the dorm. And then the alternative, she is testing whether or not her friend has the right percentage. So that suggests a two-sided alternative, that the proportion of all students that live in the dorms is not 0.6 or is different from 0.6. Now, we're supposed to write this hypothesis in words and in symbols. I don't know if I have room for both, but this is one of the reasons why we like symbols, is because that little symbol pi stands for all those words that are written there. So the null hypothesis is that 60% of all students at Sasha's school live in the dorms. And the alternative hypothesis is that the proportion of all students at Sasha's school that live in the dorms is not 0.6. I'm abbreviating a little here. I'm leaving out at Sasha's school just because I'm running out of space. Okay, but a couple things to notice with this. So our hypotheses are about the parameter pi. They're not about what happened in the sample. We don't have to make a hypothesis about whether the sample proportion is 0.6 or is not 0.6 because we already know that it's 51%. It's definitely not 0.6, right? But our hypotheses and our conjecture and our research is about all the students at the school, and we're trying to understand something about all those students based on looking at 148 of them in the sample. All right, part B, assign appropriate symbols to the numbers 148. That's the sample size. And 51%, which is the sample proportion of success, and in this case, success is living in the dorm. So the 51% is a p-hat, and I'm just going to make a note here to make sure everybody understands how that came about. If you take 76 out of or divided by 148, that would give you a proportion of 0.51. So when our variable is categorical, pi is the symbol for the parameter, and p-hat is the symbol for the statistic, the actual observed proportion of successes from the sample. All right, part C. The null distribution in this problem has an approximate standard deviation of square root of pi times 1 minus pi all over n. So note to self, that's on your formula sheet. They want us now to calculate that standard deviation, so we need to plug in the appropriate numbers. Hang on. I gotta hang on a second. I don't know why this thing's not working. I messed this up somehow. All right, I didn't really need to highlight that, but I couldn't figure out how to get out of it. I apologize for that. Okay, so they want us to calculate this square root. Question is, what number do we put in for pi, right? We know that n is 148. We just did that in part B. But what about pi? So remember that sometimes in class I've put a little subscript 0 on this. That is, pi is the value that's assumed for the parameter in the null hypothesis. So we're going to put a 0.6 times 1 minus 0.6 all over, again, n, the sample size is 148. So if I were you, I would pause the video here and try to calculate this for yourself. Make sure that you can calculate it with your own technology. And when you plug in the numbers, you should get approximately 0.04. And if you're not getting that, then you need to let me know, and we can figure out what's going wrong there. All right, next, calculate and interpret the z-score for the observed sample statistic. Again, the observed is highlighting just because I don't know how that happened, but it doesn't mean anything important. All right, so z-score formula is also on your formula sheet. That is the observed statistic minus the mean of the null distribution over the standard deviation of the null distribution. Now that's written out on your formula sheet. And the reason why, so you might have in your own mind statistic minus mean over standard deviation, and that's okay, except sometimes that can lead you down the wrong path because the standard deviation has to be the standard deviation of the null distribution. In this example, there is no other standard deviation, but in other examples there will be, so we have to be careful of that. All right, so the observed statistic is our p-hat value of 0.51. The mean of the null distribution, how do we know? We didn't actually create a null distribution, but we know that the mean of the null distribution comes from the assumed value of pi in the null hypothesis, and then the standard deviation is what we just calculated in part C. Now again, if I were you, I would pause the video and try calculating that for yourself. Make sure that you can get the correct answer. It should come out to be negative 2.25. Now they asked you to do an interpretation. I'm going to write that over here. So the observed statistic of 0.51 is 2 1/4 standard deviations below the mean. That would be 0.6 of the null distribution. So our question in general to run our statistical analysis is, we can obviously see that 0.51 is different than 0.6, but our question is whether it's enough different to be found in the tail of a null distribution. So that's really what we're trying to figure out here. So the z-score tells us how many standard deviations away from the center of the null distribution is our observed statistic. And in this case, notice I don't have a negative sign on the 2.25 in the sentence written in red, the interpretation, but I use the word below, and that takes the place of the negative sign. Then in part E, we want to evaluate the strength of evidence against the null hypothesis. So you again have to look on your formula sheet where you have those strength guidelines written out. Take a moment, pause the video, and make sure you can find the level of strength based on the z-score, and you should find that there is strong evidence against the null hypothesis. So that's what I call the initial conclusion, evaluating the strength of evidence against the null hypothesis. Then we're also asked to state a conclusion about the research conjecture. The conjecture, generally the alternative hypothesis, is whether the proportion of all students that live in the dorms is different than 0.6. And so if we have strong evidence against H0, that means we have strong evidence for the alternative HA. So we could say there is strong evidence that, and then we can write down the alternative hypothesis, the proportion of all students. And again, this is a statement about all the students, not the 148 students in the sample, but all the students at the school that live in the dorm is not 0.6. So again, if we have strong evidence against H0, we have evidence against the proportion pi being 0.6, then our evidence suggests that the proportion is not 0.6. Again, really important to have the word all there and have it, I would underline it if I were you, to remind you that this conclusion is about all the students at the school, even though we only looked at a sample of 148 students. Now, the last thing is to use the theory-based inference applet to find a theory-based p-value for this test. So we're going to go to the applets, and again, take a moment, pause the video, math.hope.edu/isi, and go to the applets and follow along. So we're going to use the theory-based inference applet. Our scenario is one proportion, so we're going to leave that the way it is. Our value of n is 148. Now here for the count, we could put in the 76 students, and then if we click out of that, the 0.51 is put automatically in for p hat, and we see that it's actually 0.5135. If instead you put the 0.51 in for p hat and clicked away, then the count would be filled in automatically, and I believe it would actually come out to be 0.75, which is a little bit closer to 0.51. So the moral of that story is, if you're given the actual count and not just the p hat value, then I would recommend that you use count in this theory-based inference applet and let the computer calculate the p hat for you. All right, now we're going to do a test of significance. We got to go into the H0 and change the value to 0.6. And when you click out of that, the other box automatically gets a 0.6 in it. So the number value in the hypotheses should be the same in H0 and HA. And then we can change the sign in the alternative hypothesis to a not equal to. So we're doing a two-sided alternative, and you notice when you hit calculate, a second part of the right-hand tail gets shaded. And so we're shading in two tails the area or the dots, if we could see the individual dots, that are at least as extreme as the observed 0.51. So here's, well, I guess I can't do that. Never mind. I can't write on this. I wasn't thinking. So notice the z-score here is negative 2.15. which is close to what we had, negative 2.25. There's a little bit of rounding error, and that's why they're different, but they're close enough. And when you're using a theory-based method, everybody's getting the same z-score, and everybody's getting the same p-value. So our p-value here is 0.0317. When it's based on theory, everybody gets the same, whereas if you were going to do a simulation, everybody would not get the same p-value. So 0.0317, if we go back to the worksheet, the p-value is 0.0317, and the z-score is negative 2.15. All right, so close to what we got in Part D. We had some rounding error, so that was the problem with that. Why it came out different, but it's pretty close. Oops. And note to self, this p-value, again, pause the video and look at your chart of strength guidelines. When your p-value is between 0.01 and 0.05, that gives you strong evidence against the null hypothesis, which is the same strength that we got from the z-score. So again, didn't specifically ask us to do that, but it's a good idea to just double check.